Welcome. On this channel, I do unscripted, unedited videos about Linux programming and stuff. If you're new to the channel, you should probably check out video 1, kind of explains the format. And if you want to catch up with the project I'm currently working on, this game, you might want to check out video 23, I believe, which kind of describes it. Right now, I am going to kind of pick up where I left off in the previous videos. We created a module for loading the environment, loading the config, right? So the config that the app will start up with, and then another one for loading the game state. So one of the well, I'm not sure that it directly applies here, but one of the restrictions that I'm putting on the development of this game is it has to run on a single server. It's going to probably have a kind of a failover mechanism like you would do with a database, a single host database, where it's got a state and a wall log, and I guess that's kind of redundant, a write-ahead log. And when the second instance comes in, it's going to load the most recent state that's available, then follow the write-ahead log until it catches up, and then restart, and then take over for the server, basically. And so that's what those pieces are about. In the previous 2 videos, we added the basic code for that. There is more to do there. Kind of even going back a step, what I'm really doing is I'm just trying to work through all of the things that the server does on startup. Kind of just an empty, thin slice of what the behaviors will be so that I can start to iterate on them. So clearly, I don't know what I'm doing, obviously, so I need to just kind of do things so that I can learn on it, learn what to do. So let's start by taking a look at the notes file. A couple of videos ago, I was kind of talking my way through this. The basic idea is that this server is only ever going to be written in C. Okay, so the overall idea of the channel, of what I'm doing here, is to be able to experiment with interesting code, right? Have a reason to write code and do interesting things. Now the server, I want to dive down, assuming that I stay with this for a long enough period of time, I want to get to where I dive down into like real performance stuff. The clients are going to be more about experimenting with different technologies. So I might write one in Rust, I might write another in Go, I might write a Windows or a Mac client, and they all may be completely different, or a web-based client, and they could all be completely different technologies. So the client is where I'm going to experiment with technologies, and then the server is me hopefully someday getting to the point where I can really experiment with kind of the performance side of the whole thing. Let me think here. The server is only using environment variables. So one of the things that I'll do here when I actually get to working on the code is we'll get it's .env and then local envrc files so that we can easily modify our local environment on the server. I haven't actually decided this. I was saying in the last one that the server is almost certainly going to be so I'm almost certainly going to be distributing it via a Docker image. The alternative to that is down the road I may experiment with doing it as a Nix build. But part of what I'm approaching here is the server, I only have to worry about one way to deliver it because I will be running it. The clients I want to make, I want to distribute them in as many ways as possible so that anybody could use them, is the idea. And so I want to see, all of these things are assuming that I stick with this for a really long stretch of time. but it would be really wonderful to see the clients distributed in distro packages, in as an app image, or what other is Docker files, as whatever is normal, for that particular platform. What is the most reasonable way for it to deliver? So not only do I get to play with writing it in various different languages, I also get to, I get to have the exploration of, well, what's it like to try and to distribute an application to all these different platforms? Again, assuming I stick with it. I keep saying that like I won't, but I will to some degree, to some point. But 4 or 5 years down the road, it's hard to say that I'll do yet another client. Who knows what we'll do, right? Okay, and then I started talking a little bit about what's going on right now, which is just kind of getting a basic shell of a server and then a basic shell of a client. The first client will just be the CLI client. So the server itself has to first spin up. It's going to read all of its config out of environment variables. It's going to read the state file that it's passed, and then it's going to try and follow up the wall to modify the state so that it's completely caught up. It enters the main loop. It starts accepting connections, processing those connections. Eventually, it's asked to shut down. And then it does those things, right? Close connections is one of them. But the other one, the one that I was really going to write is, okay, so we need to disable Copilot, disable. The other one that I was really going to write here is it needs to write the state. So flush wall and write state. That's what it does when it shuts down, right? So what that allows then is the next process to start with the state, and in theory, let me think this through. Does it really have to flush the state? Well, it has to flush it to disk for sure, but the new process starts up, reads the state, then starts following the wall. I think that the idea is, this is really going to come crystal clear when I start working on it, obviously. But I think that the idea is when it's asked to shut down, what's going to happen is the new process is going to signal it and say, hey, I'm ready to shut down. And what it will do at that point, what the original server will do at that point, is simply flush the wall as it is, right? Whatever's in its buffer. Then the last line of that flushing of the wall is going to be some, transfer of control. So when the oncoming process is reading the wall and it sees that everything has been flushed, and by flushing, it's literally just writing it to disk. It's not even necessarily updating the state at this point. That will trigger the new process to take over, basically. So what it really looks like is this is a tight balance. So it's close the connection, flush the wall, and then what happens is the new process sees the end of the wall, opens the connection, and then starts to process new connections, right? So what the new process would have done is it's actually always starting out with the state from the previous shutdown and then playing through that whole wall. I don't know if that's a good idea. That's how I envisioned it. Anyway, this is all an experiment, and I have no idea if any of this makes sense, or we just end up running a little you know, if I end up finding a completely different way to do it. But what I'm going to do in this video is kind of I think jump back. So I was reading the state here, but we need to write the state too at some point. And I don't have write the state implemented. It should be pretty straightforward to implement, but what we have is I don't want a v-split. Oops, I didn't mean to do that. State. So we have a state load, which so we have a print, and we have a, oops, so we got so roughly speaking, what I have going on here is I don't know, again, being completely new, coming back to C, truly not remembering anything from 25 years ago. I don't really know if this is a good way to go about writing it. I haven't read enough other code. It's a thing I need to do more. But I have decided on this pattern, at least for all of my own code, which is that I'm always returning an enum from, we'll have to see if there's conditions when I do and don't do this, but for the time being, I'm always returning an enum from my functions, and that enum can be turned into a string to tell you what it means, and any actual usable values are being returned as pointers that are passed in generally, right? One of the, well, I don't want to go into that. What I will do, though, is I want to do state write. And so I'm going to do that here. So what we're going to be passing back after state write is, of course, a state result. It is not state load that I want to do. It is state write. It could be flush. It's going to be right. What we're going to take here is the file name. Do I want to do it that way? Do I want it to determine its own file name? For now, I'll just have it take a file name, and it's going to take the state that it's going to flush, right? What we're going to end up doing is opening a file with the file name for writing. It's going to return unable to open file. State unable to open file. That is fine. It didn't have to get rid of any file pointer. That is the return from this. It is an error. Okay. If it opens the file for writing, it is going to record the number of records written. That is right. It's going to write the state, passing the size of the state. There's only one of them. We're passing the file pointer. All good. If the records written is equal to 1, we close it. If the records written is not equal to 1, we just close the file and but this is wrong. It made its best guess. It didn't exist. What I want is unable to write. Oops. Write file. Oops. Unable to write file. And we need to add an unable to write file. Error, failed to write state file. We close the file, and we return. It's not state success, though. It is going... Oh, yeah, it's state success. I'm in the state, not config. So that does not build. Expected. So where was that? Line 13 of the header. Well, that is interesting. And then I'm missing failed to... okay, warning, format %d expects argument of type int, but argument 2 has type int pointer, and this is in line 24. So we go to line source, space captain, 24, st count. Is that really? So out of curiosity, can I do that? I can. Okay, so now if I write this, we blow up. I guess we have to figure out where. So nothing tried to... nothing... what are we doing here? What's going on? So I print out the path, and then... so it's in main. Heap use after free is what I was looking for. So let's take a look here. Is it this? Is it? Yes. Okay, so what's happening is state is getting freed prior to this. And why is that happening? Well, to start with, I know I'm going to need state read. State write, I mean. Which takes blah, 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 blah. CFG becomes ST. Okay, it all builds cleanly. But for some reason, so if we follow it through, we create the state pointer, we actually load state, assuming that we don't fall in the error here, and exit, we're fine. We should still have state when we get here. But we don't. It's saying that we have freed the heap related to that. Okay, so if we go, the only state print, we're not doing any frees down here. The only place we do a free is, I mean, we can call it explicitly. Or was it telling me it wasn't free? No, it's telling me it was used after free. Okay, so that means we're getting an error. The only thing we're calling is to load. So let me swap these so you can see it. I'm just going to, actually I should have just, I just want to see if I'm falling into one of these. I must be falling into one of them, right? It's the only explanation. But I printed out, so I've already, at this point, I've already made it back to, you know, because the only place I'm printing, let's swap so you can see. So the only place I am printing I know that I'm not getting there, but I'm going to inspect it anyway. The only place that I am printing that path is right here. Then I free it. But what it's telling me is that keep use after free. And it's telling me I'm doing it I am totally missing something. I mean, it should. I always go into these videos thinking I'm going to do one thing, and I end up doing something completely different because I still don't know what I'm doing. So just for the record, we're going to put one of these here. And I should see, yeah, I mean 4 wasn't the right value, it would have been 5 at this point, but, so it gets there just fine, but then I reference it here and it blows up, so, this is, nothing in the world should be calling state right. It doesn't matter to anything. And this malloc happens here, and it does free. Oh. That would be it. Oh no, that wasn't it. This is it. I was actually freeing it. This keyboard. I was actually freeing it. The most obvious thing in the world, I was just actually freeing it. So now if I run this, no issues. Let's just make sure I wasn't making the same mistake in config. I must not have been. Nope. I was not freeing it. Okay, so let's find all these puts I just add. Then let's come up and do what we were originally going to do, which is on shutdown, the last thing it needs to do is write st results equals state right argv1. That's fine. We can write it back out to, now let's write it to a different place for the time being for debugging purposes. So so we're reading it from, we'll read it from state and write it to dump dat for the time being. Now let's come back over here again. So we open it, return an error if we can't. We write the size of the state and then close it. And this should be unable to write file. And then we close it and return success. Seems good. So now if I run it, I'm getting did I get an error in the make file? It seems like I did. Make file 55 run, error 1. Make run. So if I do space cap, bin space captain, debug, and state dat and dump dat. Oh, heh. That's what happened. So I had I did actually have an arg check in here, arg count check. So it was just returning an error. Okay, and so now there is a state dat and a nothing changed in those states, so they should be identical. So if I cat state dat into cat dat or cat dump dat into base 64, we get the exact same thing. So that's exactly what we expect. And I'm going to call this video good at that. Let's wrap it up. I'm going to status. So, darn, I think I'm pretty sure that this is 30. I would need to, okay, so let's add, let's just add anything, dat. Let's just add it all. Okay, so at the end of the videos, I know that I want to be committing these, and at the beginnings of the videos, I want to be tagging them as the kind of the plan I developed. But what we're going to say about this one is added state right. There we go. That is that for that one. I will see you in the next video.